In this video, we're going to go over another technique for solving circuits, and that's loop analysis. So anytime you do loop analysis, you're basically going to create these meshes. And a mesh is very important. A mesh is going to be a loop inside each section of your circuit. So let's go ahead and draw two of them. And remember, when you draw your loops, make sure they go in the same direction. So we'll do I1. And these loops represent current. We're going to call this current I1. So that's going to have the same current because these are all in series here, going this way. Now we're going to have loop I2, and it needs to be going clockwise just like I1 is. So there's I2. So now we know that this 6-volt source, this 6-volt source, this 6K ohm resistor, they're going to have current I2 running through them. So is this wire is going to have current I1 along with the 2K ohm and the 4K ohm resistor. Now, this 3-volt source and this 2K ohm resistor, they share I1 and I2. So that's where the math's going to get a little bit trickier. So now we're going to write KVL, Kirchhoff's voltage law equations, for both of our meshes, because this is mesh 1 and this is mesh 2. So let's start with I1. Word of caution, this is where the math gets kind of confusing looking, just because of all that's going on. I encourage you to keep all your units written down and don't take any shortcuts and be extra careful. If you get these problems wrong, you're probably messing up your unit somewhere, or you're putting a negative where it should be positive or a positive where it should be negative. So let's go through I1. So before we even start writing stuff down, we're going this direction. So let's write plus minus on our resistors. Let's keep their orientation correct. And let's just go ahead and call this the positive and this the negative side of the 2K ohm resistor. As long as we're consistent, that's all we need. And then this way, we're going to do plus and minus on the 6K ohm resistor. Remember, when the arrow goes around and hits an element, such as this resistor, its sign is going to be this. So this hits the positive first, so it's going to be positive 2K ohm, positive 4K ohm, positive 2K ohm, so on from there. Unlike I2, it's going to come up and it'll hit the negative of that 6 volt first, so it'll be negative 6 volts. I'm going to leave these two guys for later because that's going to be a little bit more involved. All right, let's start here. So I1 is coming around. We're going to hit that plus. So we're going to have 0 equals I1 times 2K ohm. Then it's going to continue to the 4K ohm resistor. So now we'll have I1 times 4K ohm. Now we're going to define these shared components. So we're hitting the plus first. So we'll do plus 2K ohm. But the current in that resistor is I1 going this way and I2 going up. So it's going to be the difference between them. So we're going to do I1 minus I2. Now we get to the 3-volt source. Again, we're still going down this way. We're going to hit the positive first, but because this is just a voltage source, we don't have to worry about its current. We just know it is 3 volts. So we'll do plus 3 volts. Now we're going to do some simplification. Let's get that 3 volts over to this side. Now we're going to do our distribution to the 2K ohm to the I1 minus I2. Now we have negative 3 volts equals I1 2K ohm plus I1 4K ohm plus I1 2K ohm minus I2 2K ohm. So let's combine our like terms. So now we're left with negative 3 volts equals I1 8K ohm minus I2 2K ohm. Now let's move on to our I2 loop, or mesh number 2. Same thing, we're going to start with 0 equals. Now let's start here. So we're going to start with this negative 6 volts. Then we're going to come down to this positive 6K ohm resistor. So that'll be I2 times 6K ohm. Then we go up to this negative 3 volt source. And now again, we're back at our 2K ohm resistor. That's going to be shared. We're hitting the negative side first, so it'll be negative 2K ohm. And keep it consistent with whatever you used up here, use down here. So that's I1 minus I2. Consistency is the key. So now we can do a little bit of simplifying. We have a negative 6 volts and negative 3 volt for negative 9 volts, which we're just going to put on this side. So 9 volts will equal I2 times 6k ohm minus 2k ohm distributed into I1 minus I2. So let's go ahead and do that distribution. All right. And we have 9 volt equals I2 6k ohm minus I1 2k ohm plus I2 2k ohm. Let's combine our like terms, which will give us 8k ohm for I2. So now we have two equations with two unknowns, and that's just a system of equations that needs to be solved. But for this, let's actually use some linear algebra. So I want to take our two equations, I'm going to go ahead and star them, and I'm going to make myself some space. So first, I want them to look the exact same. I want the voltage, I1, then I2 in that order. So equation 1 here is already set up like that, but we're going to just write it down here. But 9 volts we have equals I2 8k ohm minus I1 2k ohm, so I'm going to switch those around to keep everything lined up. Now we can see from here, we can make a matrix out of this. So let's do a matrix of Ohm's law. We're going to have V equals IR. So let's start with a 2 by 1 matrix over volts. So we're going to have -3 and 9 equals our currents, which are I1 and I2. Currently, those are the unknowns. And that's multiplied by resistance, which is going to be 8,000, -2,000, -2,000, +8,000. So let's write that out. We have 8,000, -2,000, -2,000 again, then +8,000. So now we can treat this as V equals IR. So move R over, V over R equals I. But what we can do instead is V R to the -1 equals I. So now let's break out the calculator. And let's put these in. So matrix, let's go ahead and do number 1 will be our small one. So make it 2 by 1, -3 and 9. Done. Now for our 2 by 2, 8,000, -2,000, -2,000 again, and 8,000. Second quit. Okay, so we know we need the resistance to be inverted. So we'll do, take that one, raise it to the power -1, multiply it by our first one, and this gives us 1 times 10 to the -4 for I1, and that's going to be in amps. I2 equals 0.0011 amps. So now if we can put those into milliamps, and that's just going to be, I don't want to forget my negative. Now we have negative 0.1 milliamps and 1.1 milliamps. So those are our currents. So I'm just going to write those up here. And now we can use what we have to solve for V naught, which is going to be the voltage from here to here. In other words, the voltage across that 6k ohm resistor. So V equals IR again. V naught is going to equal whatever I2 is times the resistance, which is 6k ohm. We can go ahead and fill in I2. So we have 1.1 milliamps times 6k ohms, which means V naught equals 6.6 volts. And that's our final answer. And that is loop analysis using mesh currents.